All right, so if you do my method, you might be getting good at that. You're thinking, what is the largest perfect square that's hidden inside of 80? What is that? Let's try a little bit higher.
16.
Right, let's change this to 16 times 5. Square root of 16 is 4, so my final answer is 4 root 5. I've simplified that down as far as it can go. If you're good at doing it that way, awesome. I'll do the other way real quick just as a reminder. 80 divided by 2, 40 divided by 2, 20 divided by 2, 10 divided by 2. Well, I shouldn't have put a box around that one because he's prime. Once we get to a prime number, we're done. Since this was 2 times 2, that's what squaring a number means, so it gets to move out. 2 times 2, that's what squaring a number means, so it gets to move out. But this guy does not have a buddy. He has to stay inside, so 4 root 5. Whichever way you do it is fine. Make sure you can simplify a radical. Here's another one for you that we did last time. Simplify this for me. As a quick review. 5 over root 45. I wrote it in a lot of steps. You might have gotten there faster. You might still be working on it. That's fine. It's up here. I ask questions today, no matter what we get to. I had a kid in last class say, I don't know how to do long division, because we're going to do that in a minute. If you're in that boat, ask me so we can do it together. All right, the next one I'm going to write up. It's going to seem super easy. You're going to want to write the answer immediately. Most of you are going to get it wrong. So let's see if you remember. This is our last review problem before we jump into the new stuff. Please write the answer to that. And then if you get it wrong right now, you're never going to get it wrong again after this moment. There. So why did I write plus or minus 5? Did anyone get that? Did anyone write it? If you didn't, that's fine. That's something that people forget. But because 5 times 5 is 5 squared, which is 25, definitely. Same thing, negative 5 times negative 5 is negative 5 squared, which is also 25. So we always have the positive and negative version when we're working with squared, or any exponent that is even, we do the same thing. Odd ones, not so much. Today we're only working with squareds because we're dealing with quadratics. Okay, new stuff. First sticker, so figure out where you would like to put it on your notes. There's one of these that we won't use today. I'll tell you about that in a minute. I'm going to put mine right here. All right, so we've been talking about this, the whole unit of parabolas, of quadratics. zeros, roots, x-intercepts, those words all mean the exact same thing. So the x-intercepts of a graph, so that's always where we have an x, 0. Our y is always 0 at the x-intercept. So in this first little graph, we have 2 of them. So we would say this has 2 solutions. That's nothing new, just a quick review. We would say that these are unequal roots is this one, let's say, is at 1, 0, and this one is at 4, 0. So these are obviously unequal roots. So if you see that term, that's all it means. They're not the same. Down here we have one solution. So let's say this guy is at 2, 0. That's the solution, the x-intercept, the root to this parabola. We call this, and we'll talk about this more in this unit, equal roots, even though we only see one. And then up until today, we would have said just no solution. We would take out the word real, and we would have said there's no solution. But now we know that if we do stretch this up into a 3-dimensional space, which actually exists, there is some solutions here. It's just not a real number solution. It will not be perfectly on the 1-dimensional x-axis. It might be an imaginary solution that we have to formulate. So for this one, no real solution. It will not, doesn't cross x-axis, and that's okay. Which takes us to our imaginary numbers. So example 1 for imaginary numbers. Whatever you need to do on your paper to help you remember what I'm about to write in this little pink box. I equals the square root of -1. So if I ask you, which we've always been told up until today, we're not going to do that in math. If I give you the square root of -100, we're just going to rewrite this as the square root of 100 times the square root of -1. So that we can represent this in space. The square root of 100 is just 10. What does the square root of -1 always equal? I. So that's my answer, 10i. Example 2, you do for me the square root of -25 and I'm still waiting for someone to call me out on example 1. What? Thank you. Plus or minus 10i is my final answer. That was a test. Good job. Now do number 2. All right, final answer for number 2, plus or minus 5i. So if you wanted to and you rewrote this as the square root of 25 times the square root of -1, that's totally fine. If you want to go ahead and recognize that's what it is, you can skip that step. Let's do this one, the square root of -108. working on it if you are. And this is a new step, so take your time. And before we write our final answer for this one, I want to make the point that anytime we have a constant number, that's what we're going to put in front. Imaginary represents some sort of variable, something unseen. So I'm going to write plus or minus 6i root 3. So we just want to put that 6 up front, and there's our final answer. All right, last one for you to practice. See if you can get to the very final answer on your own. Number 4. Let's do 2 times the square root of negative 72. So a little bit of a smaller number to simplify. And I'm just going to write the final answer up in about 30 seconds. You can talk to each other. You can try to get there on your own, whatever works best for you. See if you can represent this one. Hi. When you have it, if you have someone next to you, see if you guys got the same. I'm just doing multiple ways up here in case you're doing it however you're doing it out there. Yeah. However you broke down your 72 is totally fine. Yeah. I just did it in multiple steps just so people can, you might find yours along the way in mine, but I just tried to do it in multiple steps. As long as you got to this answer at the end, you did something right. Oh, that highlighter is not the best. Sorry about that. All right, questions about that? Is that kind of okay? All we've done is introduce an I when we have a negative. That's it, okay? Yeah. Here? Oh, wait, what did I do here? Oh, because we had a 2 out front and I took the square root of 9 that I had in here. Square root of 9 is 3. Yep, and then 2 times 3 is the 6. Yep. And then when I took the square root of 4, it was 2. 2 times 6 was 12. So I did probably more steps up here than a lot of you did there. I just wanted to put them all in case anybody else did it this way. So this was me not finding the largest perfect square hidden inside of 72. I went to the first one most people would think of. And then when they get here, some people will stop here. And I want you to see that that's not fully simplified. All right, next part. Let's do some solving equations with that. So equations with I. So sometimes imaginary numbers pop up in our equations too. But this should feel okay. I'm going to write the first one up here and give you a second to copy it down. 2x squared plus 9 equals negative 41. All right, if I'm just solving this, if I'm just algebra 1ing this, what's my first step? Right, minus 9. Minus 9, minus 9. 2x squared now equals negative 50. Next step, divide by 2. Thank you so much. Divide by 2, divide by 2. X squared now equals negative 25. What's the inverse of squaring a number? The opposite of squaring a number? Square root, right? So that's the last thing I have to do here, and I'm done. So once I square root, that cancels on that side because we did the opposite. And this is why we learned i's today, because in Algebra 1 we would have stopped here. But now we know the square root of negative 25 is just going to be plus or minus 5i. And that would be our answer, which means this is the function, the equation of a parabola on a graph. And there are two solutions. This parabola crosses the x-axis and somewhere in space at positive 5i and again at negative 5i. So two solutions. All right, second one. Try this one. I bet you can get this one all by yourself. 4x squared plus 15 equals negative 9. Find my two solutions to this quadratic. Check your answer. If you made a mistake, find it. Okay. So all we've learned so far is always square root of negative 1 is always just I. So if we ever see square root of negative 1, we just rewrite it as I. Square root of negative anything, we just rewrite it as negative 1 times that. We're good with that. I'm going to give you a minute brain break now before we move on to the next part we have to learn today. So if you need talk, look at this, process this, practice another one of these that you make up on your own. That's what I used to do in math. After I saw something like this, I would make up my own and try to solve it. So whatever will help you retain this, do that. You need to stand up, go to the bathroom. Now's the time, because what we're doing next, you're not going to want to miss that part of it. Yeah. I have no idea. That's a great question. Yeah, go ahead. Hey. You need the beginning part? Actually, yeah, sure. So the equations are good.
I was going to go in.
No, you're fine. You're fine. Actually, what I just gave you. So it's just how. Oh, I missed the video.
I'll watch it.
Okay. Well, I showed a video. So it's just any time that we've dealt with math to this point, we've seen this on a one-dimensional graph, right? So if it crosses, these are solutions. Solution, we would have said no solution. But actually, in math, this will stretch up, and we live in a three-dimensional space. So this x-axis is not flat. It actually just represents this part of space. So this parabola may not cross here, but if we stretch it up, it might cross later at some imaginary point that we have to imagine. So that's what we're learning today. So when we're solving these things, we've always been told we can never take the full root of a negative number. We still can, but we can represent that it existed with this I. So from now on in math, when you see an I, that represents we were at some point, there was a square root of a negative number. And squares always represent this shape of a parabola. So anytime we see anything that's squared, we know this is the shape of the graph. Okay. So that's what we're doing today. If we take the square root of negative 100, I can change that to negative 1 times 100. And then that is just always I. Root of 100, my final answer is 10I.
And then this one, what did you put the I in front? And then
So this was the square root of negative 6. Hi. Sorry, you're good. So the square root of negative 6, if I rewrote that, I would rewrite it as the square root of negative 1 times the square root of 6. This is always just I. This is as simple as it gets, so I just rewrite that. Over here, since this is the square root of negative 25, that is a perfect square. So I can get rid of the square root altogether. It's just 5, but because it's negative, it's 5.
so that's it. Just if it's not a perfect square, then
Yep, if it's not a perfect square, we're going to have that, but the I will come out to represent that negative 25. Yep.
Okay, and that's it.
Yep, that's all.
Okay.
Thank you. You're welcome. Riley, you had already done this, right? In the other class? Yeah, I think you guys had already. So this should be pretty, not bad for you guys. Alright guys, you hear my voice? Let's jump back. Third sticker, not the middle sticker. We're going to save the middle one for next time. Imaginary numbers. Get yourself set up. We're going to learn a pattern. I do not like to say to memorize stuff in math. I always like to explain the why something works in math, and I will explain why all of this works today as well. I'll get you one. But this is a time that if you memorize these few things I'm about to show you right now, your life will be easier. If you understand the why and you have it memorized, your life will be so much easier. So try your best today to understand the why. If nothing else, memorize this pattern that we're about to learn. There you go. You're welcome. Okay, I'm about to write a lot of stuff down. It's not going to make sense right now. It's going to make sense as we start to work through it. I to the power of 1 is the same thing as anything to the power of 1. It's just itself. It's just saying, I'm here. There's one of me. That's it. I squared is always negative the 1. That makes sense because the square root of negative 1 is always I. So squared, square root, that one works for that reason. I cubed is always negative I. And I to the 4th power is going to be a nice, beautiful 1. We're going to finish filling out this chart, then we're going to work with them. You don't have to draw the lines if you don't want. It just helps me. 1, 2, 3, none. 0.25, 0.5, 0.75, none. So as someone who got a degree in math and then got my MBA in business, I like to relate math to finance. So I like to, anytime that I can, explain math with money. That's what I want to do. So if you think of quarters when we're dealing with I's, this is a way to help you remember it. If you have 4 quarters, you have a whole dollar, there's no change, there's no decimal, there's no remainder. If you have 3 quarters, there's 75 cents. 2 quarters, there's 50, and so forth. That will help you keep this straight and learn how to memorize the pattern. This starts over. So this is all. These are the 4 things that you would need to know. I, -1, -I, 1. It starts right back over. If I say I to the 5th power now, it's going to equal I, because I'm going to start over. I to the 6th power is going to equal -1, because it's just a cycle, okay? So let's talk about why that happens. So if my exponent here, I'm going to abbreviate exponent. 1, 2, 3, 4, 5. So if the exponent of I is 1, we know, we wrote on the last page, and it is right here for you again, I is always just the square root of -1, which is always just I. So that is why this is what it is. If the exponent is 2, if I have I squared, what does that represent? Well, that's 2 i's. So the square root of -1 times the square root of -1. What is any root times itself going to give me? Whatever's on the inside. Square root of 9 times square root of 9 is just 9, right? So this is just -1. That is why that exists. If I have I to the 3rd power, I can just rewrite that as I times I squared. So I have 3 total i's, which is going to equal I times -1, which is -I. I'm going to give you some process time on this when we're done filling it out. I to the 4th power, I can rewrite that as I squared times I squared, which would just be -1 times -1, which equals 1. And the last one, to show that the cycle starts over, if I want to do I to the 5th power, that's I times I squared times I squared. See if you can write what I would write next. I is just I times -1 times -1. Which is then just I times 1. So we start right back over at the top with just I. And the cycle repeats. So those are the whys. Memorize the cycle. So the remainder and decimal part we haven't gotten through to yet, but we will in just a second. Well, let's do our first example of this. Example number 1. Let me zoom out so I can have all of this in the frame. I to the 90th power. I don't know about you, but I sure do not want to do this all the way up to 90. But I do know that this is a pattern and a multiple of 4. So if I divide 90 by 4, I can figure out exactly which one of these it's supposed to be based off the remainder. The only remainders I can get is 1, 2, 3, or no remainder. And then I know exactly what it equals. So here's the thing. If you don't know how to do long division, it's okay. Do it with me now, though, so you understand it, because soon you're going to be dividing binomials by binomials in a long division style. So do this with me if you don't know. 90 divided by 4. If you do know how to do that, go ahead and do it. If you're not sure, I'm going to reteach it real quick. 4 will go into 9 twice. 2 times 4 is 8. 1, bring down the 0. 4 will go into 10. How many times? Twice. 2 times 4 is 8. My remainder is 2. 4 will not go into 2, so I'm done. So my remainder is 2. That means that I to the 90th power is -1. Equals -1. Oh, sorry. Now I'm going to do it the way that you're going to like. 90 divided by 4, 0.5. 0.5, -1. So if you use your calculator, we're always dividing by 4. The cycle repeats. Cool? All right, next one. I'm going to put one up here for you to do. Number 2. Try I to the 103rd power. It can only equal one of 4 things. See if you can figure out what it equals. I would love it if you did long division first and then check your answer. So 0.75, remainder of 3, 3/4, however you do it, -I. All right, we're only going to do 2 more of these, and then I'm going to give you a challenge problem. All right, number 3, I to the 25th, I to the 14th, times I to the 7th, times I to the 17th. What should I do with all those exponents? Add them. Perfect. So this is not hard. Once I reduce this down to I to the 63rd power, because we just added the exponents, then what do I divide 63 by? 4. And then we get one of our 4 answers, and we're done. I'll give you a second to figure that one out. Alright, here's your next one, a little bit easier. Find it. I to the 50th times I to the 7th. Alright, here's your challenge. What I'm about to write up here is going to seem really scary, but you have learned every single thing that you need to know to be able to do it. So I'm going to put it up. I'm going to give you a minute to struggle with it and try to figure it out. This is what we're going to do next class too, but this is your challenge. If you can even get halfway through this problem before I do, that's a really great place to be. Negative 11i to the 50th plus 9i to the 44th plus 10i to the 33rd. I know I wrote that bad. Minus 10i to the 119. These are not like terms. You cannot start combining. That's all I'm going to say. So see what you can do from here. Hey.
So for this one, for like half 64,
Mhm.
I think I do it by 4 on each side.
So we divide all of them by 4 because it's a cycle of 4. So this is all it can ever be, and then it repeats. So whatever, when we divide by 4, whatever our remainder is tells us exactly which one of these it is.
Okay.
So this is the cycle we need to memorize.
So every time we divide by
Yep,
4?
every time we have I to a power, if we just divide by 4, we know exactly which one that it teaches us.
Oh, okay.
Yep, that's it.
Okay, thanks.
You're welcome. Talk through it, struggle, get it wrong, I don't care, just try. What do you mean, not allowed to divide what? Oh, nope, because they're not like terms. We can't combine them. You might be able to create like terms if you start changing some things. Almost. The first number's right. Good job. So close. Alright, I'm gonna just start writing a couple things up here, but I'm still gonna be quiet for those of you that are trying to get through this on your own. What? Because we have some real numbers and we have some imaginary numbers, and we can't put those together. But it sounds like you got pretty far. So, just be honest with me. My last class, almost every single person raised their hand, and that's exactly what should happen because it's what you've learned so far. How many of you guys started adding your exponents together? No one in this class did that? Really? I'm so proud of you. We did it here because we have just i's. We don't have any constant numbers in the front, right? So we did it there. If no one did that in here, that's amazing. So here, if you started converting these i's to the 50th power into what they actually represent by that pattern of 4 that we just learned, if that's where you started, that's amazing. Good job. We make it all go away. So in math, we are always simplifying. We're very lazy. We see all this and we think, no, that's too much. I ain't doing all that. So we turn it into things that are much easier to work with. And then it becomes a very simple, let's put my like terms together. This is called, and this is what we're going to do all next class, a complex number. Meaning, I have a real number and I have a lateral or an imaginary number as well that I need to represent. All right. After lunch, I'm going to talk to you about your grades. You have a homework that's due today. So while you guys are gone, I'm going to look and see who did their homeworks. And I'm going to put that grade in. And I'm going to explain to you how grades work because I'm finding more and more often that no one's ever explained to you how it works. You don't understand how GPAs are calculated. You don't understand how the grade book calculates your grade. So I'm going to show you using an example when you get back so that you see not doing these homework assignments really does affect your grade in a really bad way. So I want to explain it. So I'll put those in and we'll do that. After lunch, you can start your homework. It's already in Delta Math, and we'll talk about that.